Astronomers have confirmed three. A massive interstellar object is on a near-Earth trajectory. It's fast, unstable, and it's already split once. No force on Earth can change its path. If it fragments again, we're in unknown territory. This isn't science fiction. It's happening now and it can't be stopped. The interstellar object that wasn't supposed to exist. On July 1st, 2025, astronomers spotted something strange. A fast-moving object gliding across the sky, flagged by the Atlas telescope in Chile. At first it looked like any other comet. A fuzzy glow, faint tail drifting against the backdrop of stars. But it didn't behave like anything from our neighborhood. Calculations revealed it was on a hyperbolic trajectory. A path that doesn't loop back around the sun, but flies straight through. That meant one thing. It had come from outside the solar system. This was only the third time in history that humanity had caught an object from deep space. Scientists quickly gave it the name 3I Atlas, the third interstellar, following the historic cases of Oumuamua in 2017 and Borisov in 2019. If you're fascinated by mysteries like this unfolding in real time, make sure to subscribe so you don't miss the next updates. But unlike those two, this one wasn't quietly coasting by. From the start, it moved with an intensity that made everyone stop and look closer. It was clocked at nearly 60 km/s, a speed that would take you from New York to Los Angeles in under a minute. That kind of speed doesn't come from our solar system's gentle nudges. This thing had been traveling for millions of years, and it was just now flying past our world. We've only had 3 chances to see an object like this, one astronomer said, and this one isn't acting like the others. What set Atlas apart was its unusual behavior. Early orbital models showed a close pass near Earth, closer than either of the previous interstellar visitors. Worse, small irregularities hinted at something unpredictable. Unlike Borisov, which moved in a clean arc, or Oumuamua, which showed a strange shape but no drama, this object had the potential to shift course, especially if it fragmented or vented gases. By the time major observatories confirmed its path, telescope networks worldwide were already retasking cameras to track it. It's rare to see something come from another star system, said a lead from the Minor Planet Center. But it's even rarer when that thing starts acting like it might not play by the rules. This wasn't just another dusty rock from space. It was a deep space messenger, and its message wasn't clear. Atlas's discovery forced scientists to rethink how common these objects might be, and whether we're really ready to track them in time. It had arrived silently, but its trajectory would soon stir global attention. And just when it looked like the situation was settling into a pattern, something else happened. Something that made this visitor even more mysterious: the sudden split near Mars. A few weeks after Atlas was first spotted, the situation took a turn. On July 25th, astronomers monitoring the comet noticed something odd in the images. A second object, barely visible, moving just behind the main body. It was small, faint, and offset by only a fraction of a degree. But it wasn't a glitch. This was a real companion, and it was moving in near-perfect sync. Confirmation came quickly. The Zwicky Transient Facility, the Very Large Telescope in Chile, and NASA's Scout system all saw it. This was not a coincidence or camera error. Atlas had split in deep space and no one saw it coming. The event happened while Atlas was about 1.4 astronomical units from Mars, roughly the distance between Mars and the Sun. That's not close enough for a strong gravitational pull. Normally, comets only break apart when they get too close to the Sun, or a massive planet like Jupiter. That's what happened to Shoemaker-Levy 9 before it slammed into Jupiter in 1994. But Atlas was far from both, yet it had broken in two. The scientific community was stunned. Comets don't just split for no reason, especially not out there. One researcher commented, "It's like watching a vase crack in a padded room. The fragment was small, trailing just behind the main body, but its presence changed everything." Suddenly, models needed updating. If Atlas could split once, it could split again, and any new piece could veer off, potentially toward Mars or worse, toward Earth. What made it even stranger was that the two bodies were moving in lockstep. The smaller fragment didn't tumble or drift. It just followed like a shadow. That precision suggested it wasn't a chaotic break, but maybe something slower, more controlled, or just weird. Within hours, the world's most powerful telescopes were reoriented toward the event. Engineers paused their regular schedules to catch every glimpse before the fragment faded. What they captured would soon deepen the mystery. Because if this wasn't a random break, then something we didn't understand was happening with 3I Atlas. And this was only the beginning. Next came the questions. Why did it split? Could it happen again? And what would that mean for us? Why it shouldn't have broken apart. Comets do break, we've seen it before. But when 3I Atlas split, it defied every rule scientists expected it to follow. Usually comets fracture when they get too close to the sun, where intense heat and pressure build up inside their icy cores. Or in rare cases, they're pulled apart by massive planets like Jupiter, whose gravity rips them into pieces. But Atlas didn't do either. When it fractured, Atlas was still 1.4 astronomical units from Mars, far from the Sun's furnace and even farther from any planet big enough to cause tidal stress. Mars's gravity, by comparison, is gentle. It simply doesn't have the pull to shred a comet flying past at 60 kilometers, which left everyone with the same question. What caused this break? Scientists turned to the data, spectral scans, light curves, coma brightness, hoping to find signs of stress. But what they saw was puzzling. Atlas didn't show signs of spin-up. No sudden tumbling, no jets of gas shooting off its surface. Its coma, the glowing cloud around its nucleus, was stable. If there was a breakup, there should have been a spike in brightness or a sudden change in trajectory. There wasn't. Instead, the scans showed something subtle, a low gas-to-dust ratio. That meant Atlas was shedding more dust than gas, a trait not typical of highly active sun-heated comets. Some experts suggested this could point to internal weaknesses, perhaps built up over its long interstellar journey. But that still doesn't explain why it cracked when it did, or why the fragment trailed so perfectly behind. The weird thing, one planetary scientist said, is that it broke apart like it had a plan, like it knew what it was doing. Of course, that's not how science works. But Atlas was breaking the script, and it wasn't done yet. The event forced researchers to consider unseen forces, things we don't yet fully understand. Could internal pressure, trapped gases from a different star system, be acting differently than expected? Or are we seeing a kind of material we've never encountered before? Whatever the cause, one thing was clear. This wasn't normal. And if a split could happen out there, away from all the usual triggers, it meant more surprises could still be on the way. The next one could be bigger, faster, or closer. And that brings us to the one question no one could ignore. Could Earth be in the crosshairs next? Trajectory. Could it really hit Earth? At first glance, Atlas looked like it would pass by harmlessly. Its orbit was clearly hyperbolic, which meant it wasn't captured by the sun and would leave the solar system after its pass. But hyperbolic doesn't mean safe. In space, even a tiny deviation can shift an object's path by millions of kilometers. And now Atlas had deviated. The confirmed split near Mars introduced a new problem. When a comet fragments, it can redistribute momentum, pushing the main body slightly off its original path. Add to that outgassing, where jets of gas act like small thrusters, and you suddenly have an object whose motion is not just fast, but unpredictable. This is why mission analysts started running new trajectory models. Dozens of simulations were triggered in space agencies worldwide using the new data from the split. What they found raised eyebrows. Some models showed that while the main body would miss Earth, the fragment or any future debris could enter sensitive orbital windows. The comparison was immediate. The Chicxulub asteroid that caused the extinction of the dinosaurs was at one point also considered a near miss. Small changes in trajectory over time led to catastrophe. The same could happen here, especially with an object moving at interstellar speeds. The real challenge, though, is that non-gravitational forces like outgassing or solar pressure are hard to predict. They don't follow neat patterns, and they don't show up in early orbit calculations. The scariest objects, said one NASA planetary defense officer, aren't the ones we're tracking. They're the ones that change mid-flight. That's why 3I Atlas, thought to be just a visitor, became a potential threat. Even if the chance of a direct hit is low, the margin for error is razor-thin. And at these speeds, a piece the size of a car could hit with the force of a nuclear bomb. As models were being updated, tension grew in the planetary defense community. If Atlas split once, could it split again? And if so, where would the next fragment go? The answer lay ahead, and it would take us straight to Mars, where the next chapter of this mystery was unfolding. Mars in the line of fire. As Atlas and its mysterious fragment closed in on Mars, mission planners began sounding quiet alarms. The comet wasn't headed for a direct hit, but that didn't matter.